तो ये हमारा नेक्स्ट क्वेश्चन है। क्या क्वेश्चन है? द स्ट्रक्चर्स ऑफ बेरिलियम क्लोराइड इन सॉलिड एंड वेपर फेज रिस्पेक्टिवली आर। तो हमें बेरिलियम क्लोराइड का स्ट्रक्चर पूछा है। तो बेरिलियम क्लोराइड जब वेपर फेज में होता है तो ये किस फॉर्म में होता है? डायमेरिक फॉर्म में होता है। कैसे? बेरिलियम क्लोराइड, 2 क्लोरीन, और दूसरा बेरिलियम कैसे होता है? यहाँ पे बेरिलियम, ये क्लोरीन। ठीक है, तो ये डायमेरिक फॉर्म में हमारा कैसे होता है? यहाँ पे आपका कोऑर्डिनेट बॉन्ड बनाता है। ठीक है, तो जो वेपर फेज है उसमें आपका बेरियम क्लोराइड डायमेरिक फॉर्म में होता है, लेकिन जब आप सॉलिड स्टेट की बात करो तो ये स्ट्रक्चर जो है वो एक्सटेंड होता जाता है। यहाँ पे फिर से आपका क्लोरीन अगले वाले बेरिलियम का, और ये ऐसे आपका जो स्ट्रक्चर है ये एक्सटेंड होता जाता है किसमें? सॉलिड स्टेट में। ठीक है, तो आपका वेपर फेज में क्या होता है? डायमेरिक होता है, और सॉलिड स्टेट में कैसा होता है? चेन स्ट्रक्चर होता है। ठीक है, तो ये आपको याद ही करना पड़ेगा कि बेरिलियम क्लोराइड कैसे एग्जिस्ट करता है वेपर फेज में और सॉलिड स्टेट में। तो इसका जो आंसर होगा वो कौन सा होगा? सॉलिड स्टेट में चेन और वेपर फेज में डायमेरिक। तो इसका आंसर होगा आपका फर्स्ट ऑप्शन।
Hello everyone, this is our question. It says that magnesium powder burns in air which gives. Actually we know that air is a mixture of nitrogen and oxygen which are major components. Here nitrogen is 71% whereas nitrogen is 78% and whereas oxygen is 21%. So that's a major component. That means here when magnesium reacts with oxygen, it reacts with both nitrogen as well as oxygen. Is it right? So when magnesium reacts with oxygen, it will form magnesium oxide. Magnesium oxide. Whereas when the magnesium reacts with nitrogen, it will form magnesium nitride, Mg3N2. Mg3N2, magnesium nitride will be formed. So based upon this, the answer will be option 2 with magnesium oxide and magnesium nitride. Hope you understand, guys. Thank you.
Our question is the covalent alkaline earth metal halide is. This question can be explained using Fezan's rule. The postulate of Fezan rule are: first is size of ion. Smaller the size of cation, larger the size of anion, greater is the polarizing power and greater is the covalent character. And here what is polarizing power? Polarizing power is the extent to which cation can polarize anion. It is proportional to the charge density. Charge density is the ratio of charge to volume. So polarizing power is directly proportional to charge density. Second is charge of cation. Greater the charge of cation, greater is the covalent character. Third is electronic configuration. For cations with same charge and size, the one with n-1d and ns20, which is found in transition element, have greater covalent character than cation with ns2np6 configuration, which is commonly found in alkali or alkaline earth metal. Now with the help of Fezan's rule, we will determine the covalent alkaline earth metal halide. In the given option, let us see. In the given option, as we can see that here, halides are same. Halide atom is same. So covalent character will be decided on the basis of metal atom. So it is decided on this metal atom. Okay. So from here we can say that metal is positive and halide is negative, which is same. So anion is same. So in metal charge, electronic configuration is same. So it will magnesium halide, calcium halide, strontium halide, and barium halide. Beryllium halide, sorry here. Beryllium halide. So as we see that this is on the basis of change in size of metal. So according to the Fezan's rule, smaller the size of cation, more is the covalent character. Here we can say that beryllium is in small in size and its cation is small. So size of smaller the, according to this, beryllium has smaller size of cation here. Okay, so from here we can say that beryllium has the smallest size, therefore it have more covalent character. So option 4 is the correct answer of this question. Our question is the amphoteric hydroxide is, first we know about that what is amphoteric substances. Amphoteric substances are those substances which can react both as acid and as a base. Amphoteric species are also known as amphiprotic molecule. Which can either accept or donate the protons. These amphoteric substances will react in order to give salt and water. The amphoteric hydroxide can act as both acidic as well as basic hydroxide. The amphoteric hydroxide will act as acid or in base depending on the reaction condition. The metal hydroxide with highly charged central metal atoms are amphoteric oxide or amphoteric hydroxide. Some metals such as aluminium, zinc, beryllium, lead can act as amphoteric oxide or hydroxide. These hydroxide will form amphoteric hydroxide based on the surrounding substance's pH. Let us move on the given option. First is magnesium hydroxide. Magnesium hydroxide is act as basic hydroxide. So from here this is incorrect option. Second one is beryllium hydroxide. It is amphoteric hydroxide. Let us see. Beryllium hydroxide are amphoteric in nature since it can react both with acid and base. Let us see the reaction. Beryllium hydroxide plus HCl, it will give beryllium chloride plus water. Here 2, here 2. Okay, and beryllium hydroxide react with sodium hydroxide. It will form Na2Be OH whole 4. Okay, so from here we can say that option 2 is the correct answer. It acts as amphoteric hydroxide, beryllium hydroxide. Calcium hydroxide act as basic hydroxide here. So this is not correct. Let us say for strontium hydroxide. Strontium hydroxide will act as basic hydroxide. So this is also incorrect. So option 2 is the correct answer of this question.
Hello, so let's start solving the question. And question says that the metal used for making the X-ray tube window, right? So it is a kind of memory-based question, but you have to understand what X-ray tube is, right? So before doing this question, let us understand understand that what is actually X-ray tube, right? Here you can see the picture of X-ray tube, and there are 4 to 5 components, right? So here you can see that this is our cathode, right? This is our cathode, and this is our anode, right? And from the electrons are ejected from the cathode because it is connected to the negative terminal, and cathode is connected to the positive terminal, right? So that means there's a, you can see there's a filament, and this filament is made up of tungsten, right? Tungsten. So here you can see that this filament is made up of tungsten, right? And when heat is required, right, so heat is supplied to this filament so that it can become heated, and so electrons are ejected from this cathode compartment and they are targeted to the this anode compartment, right? So now our main focus is to generate the X-rays, right? So this anode just simply converts the energy of the electron into the useful X-rays, right? And these are the X-rays, right? These are the X-rays, right? And this here you can see that this is our X-ray window, right? X-ray tube window. And now question says that from which metal this window is made of. So you can easily see that this window is transparent, right? So because X-rays are coming out from this, right? So beryllium metal is used for making this window. So our option will, correct answer will be beryllium metal, right? So let us deeply understand this, what actually beryllium metal, how beryllium metal works, right? So beryllium metal actually is transparent to the this X-rays, right? So it is sufficient to handle the vacuum which is required for the X-rays to operate it, right? And here you can see that this is our envelope, right? So this envelope is necessary because the heat that is evolving is to so the heat evolving, so it can handle it very clearly, or you can say that it can handle it very efficient, in a very efficient manner, right? So these are the some setups of X-ray tube, and the metal used for this X-ray tube window is beryllium, right? So hope this answered your question, so thank you.